Let's look at the trigonometric functions in detail. So here we're dealing with an xy, a coordinate plane. This angle is in standard position, so the initial side is along the x-axis, and the terminal side here is labeled as r for radius. You may remember that much of trigonometry actually has to do with circles rather than with triangles. So that's where we're headed with this labeling. Along this radius here, we've chosen an arbitrary xy coordinate. So now we have a right angle triangle that's created when we drop a vertical line straight down to the x-axis. We have an x side, a y side, and an r side, and trigonometry will describe the ratios of these sides. Now this xy coordinate was chosen arbitrarily. This would work just as nicely if we'd chosen an xy coordinate that's a little bit closer to the origin. If we dropped a vertical line straight down, we still could have labeled a y, an r, and an x side. Similarly, if we'd chosen to extend the ray and create a larger triangle, again a right angle triangle, we'd still have a y side, an x side, and an r side that we could label. These are similar triangles, which means that their angles are the same. And importantly, it's this angle that we're interested in. This angle is the same for all three triangles. What else is the same? Ratios of any two sides. The ratio of side y to side r is the same in the smallest triangle, the medium triangle, and the largest triangle. You can do that with any two sides that you choose. So we can write it down in this way. If we're interested in the ratio of y to r, so the vertical side to the hypotenuse, we call that the sine of the angle. If we knew what the ratio was, we could determine what the angle must be that gives that ratio. If we know one of the two side lengths, either y or r, along with the angle, then we can certainly find the other one. So it's not that the side lengths are constant, but with a constant angle, the ratio of the side lengths is constant. If you're interested in the ratio now of x over r, well, that's the cosine ratio. The cosine of an angle is defined as the ratio between the length of x to the length of r. And then finally, the tangent of the angle is defined as the ratio of the vertical side to the horizontal side. Vertical and horizontal is only true for the diagram that I currently have, but it will remain true for the coordinate plane. So really we should define this in relation to the diagram. And of course you may also know this as well. The vertical side is opposite the angle. The x side is adjacent to the angle. And r is more commonly known as the hypotenuse. It's the hypotenuse of the right angle triangle. So you can use either convention. When we talk about angles that are outside of the first quadrant, it's important that we can relate them with y, r, and x. But when we're talking about simply triangles, right angle triangles, it's okay to use the adjacent, opposite, and hypotenuse nomenclature. So once we've defined the trigonometric functions, we can quite easily define the reciprocal trigonometric function. If you remember what reciprocal means, the reciprocal of 2 is 1 over 2. The reciprocal is 1 over that number. Similarly, if I have 3/4, the reciprocal of that would be 1 over 3/4, which turns out to be 4/3. So essentially, taking the reciprocal of something just means flipping the fraction on its head. So we're going to take the reciprocal of the left side and the right side for each trig function. The reciprocal of sine theta is then just 1 over sine theta. But we don't normally call it that. 1 over sine theta, or the reciprocal of sine theta, has its own symbol, its own definition, and it is the cosecant of the angle. So we've taken the reciprocal of the left-hand side, now we'll take the reciprocal of the right-hand side, so y over r becomes r over y. So cosecant is the reciprocal trig function for sine, and the ratio of sides is r over y. Similarly, we can take the reciprocal of cosine. The reciprocal of cosine is designated the secant. The secant of theta is the ratio of r over x. And the reciprocal of tangent is called the cotangent. The cotangent of the angle is then the ratio of x over y. Now we can do without these reciprocal trig functions. I'll just highlight what they look like here. We can do all the calculations we need with just the regular trigonometric functions, but historically, the reciprocal trig functions have been used in some applications. So it's important that we understand what they mean should we encounter them. There's one more tool that we need to solve problems in this module, and that's the Pythagorean theorem. For the given triangle, ABC, we can express the Pythagorean theorem as c squared is equal to a squared plus b squared. In other words, the square of the hypotenuse, remember that the hypotenuse is across from the right angle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So while it is common to label the hypotenuse as c, it's not the only way to label a triangle. In fact, a right angle triangle could have hypotenuse a. And in this case, we'd have to express the Pythagorean theorem as a squared, the hypotenuse squared, is equal to b squared plus c squared. So it's important to pay attention to how your triangle is labeled. As a final note, if side A is in fact the hypotenuse, then the right angle must be angle A. So we'll label it with a capital A. If the vertical side here is B, then this must be angle B, the one across from side B. And side C is therefore up here. So we always give side lengths a lowercase letter and their corresponding angles an uppercase letter. In any case, the most important part here is that we label the hypotenuse to be sure that we give the Pythagorean theorem correctly.